All right, in this problem, so somebody has a car and they're backing out of a driveway. So this is their acceleration while they're backing out, and we want to know how long it takes to reach a speed of 2 meters per second when backing out with this acceleration. So starting from rest and then moving. Then we want to know after reaching that speed of 2 meters per second, if then the car brakes to a stop in 0.8 seconds, what's the acceleration needed, right, to brake to a stop where your final velocity would be 0, and, you know, it would take this amount of time to stop. So let's break it into 2 pieces here. So part A. All right, so what do we know and what do we not know? So first off, we're looking for time. That's what we want to find. So we need an expression with time in there. So our velocity, our final velocity for this section would be 2.0 meters per second. And then for our acceleration, we would get 1.40 meters per second squared, just given by the problem here. Then for our initial velocity, because remember the car started it from a parked position in the garage, it's backing out, so it started from 0. We have an initial velocity of 0 meters per second. Okay, in this case we're going to use the expression v is equal to v naught plus at, and we're going to plug in what we have. So our vf, this is our final velocity, so 2.0 meters per second, okay, is equal to 0 meters per second plus 1.40 meters per second squared, right, times time. All right, so the first thing is how long does it take to reach a top speed, right? So how long does it take to get to what we chose as our final, v final, right there. Okay, so we're just going to basically end up with 2.0 meters per second divided by 1.40 meters per second squared. That's going to give us our time, which is just going to be equal to 1.43 seconds. Okay, so far so good. All right, so now for part B, we're already moving. Okay, so we know at part B, our initial velocity for whatever we do is now going to be 2 meters per second, right? Because that's what we're at for part B. Okay, so all right. We're applying the brakes, so our acceleration is going to change. We want our final velocity to be equal to 0 meters per second because we're deciding to stop, okay? So this is a choice. We're choosing 0 meters per second. Then our velocity is different. Yeah, and we're given our time in the problem, 0.80 seconds. Okay, so that's the information that we got to work with here. So for part B, let's see what we can do. So we're going to use the same expression. So the final velocity, v naught plus at. And in this case, we're just trying to solve for acceleration instead because we have the time, we're given that by the problem statement. Okay, meters per second is equal to 2 meters per second plus a times 0.80 seconds. Okay, so in this case, I give 2 meters per second divided by 0.800 seconds is equal to a, which is equal to negative 2.5 meters per second squared. All right, and this answer makes sense. So let's go ahead and do the does this make sense check. So if I go back to my figure, and I look back over here, this makes sense. So I'm trying to decelerate, right? So like once I come up, so I'm moving back, I've got my speed, and I want to hit my brakes, okay? And I want to slow down and stop, okay? So that means I need acceleration going in the other direction, right? I need acceleration that's slowing me down. So if I modeled this as the positive direction backing out, this acceleration would be in the negative direction because it would be opposing the motion of the car. So this is our brakes essentially acting to decelerate us here. Okay, so hopefully that helped clear some things up and that one made sense.